Hello, calculus fans. Let's talk about something called a geometric series. Last section we talked about a geometric sequence. So a geometric series is where we take a geometric sequence and add them up. So we get each successive term by multiplying the previous term by a fixed number, and this is going to be called the ratio. So the series looks like this. We start with some number, and then we do a plus ar squared plus ar cubed, and so on, up to ar to the n minus 1 plus ar to the n, and so on. So the nth partial sum is the first n terms added together. So that's a plus ar squared, all the way out to ar to the n minus 1. Why are we stopping at n minus 1 if it's supposed to be the nth partial sum? Well, we got a term here that has a r to the 0 on it, so really we're counting starting at 0 in a sense. All right, we're going to do some clever algebra. We're going to take this nth partial sum and multiply everything by r. But you should see that things got shifted. So when we multiply, we shifted things down just for notational purposes, because we can subtract. We can do Sn minus r times S sub n equals a minus ar to the n. Now we're going to solve for S sub n. S sub n is what we're going to call a finite geometric series. And we get S sub n is equal to a minus ar to the n over 1 minus r. And this is provided that r is not equal to 1. It won't work to do this if r is equal to 1. But in the end, we're not really going to care very much about what happens when r is equal to 1. Now in the last section, we analyzed this geometric sequence, the limit as n goes to infinity of r to the n. And if you recall, we said that the sequence converges if and only if r is between negative 1 and 1. It still converges when r equals 1, but not when r is equal to negative 1. So what we can do then is apply that to our sequence of partial sums, because this piece in here will go to 0 provided that r is between negative 1 and 1. And that's the only time that we're going to get a convergent sequence of partial sums. Note that r had to be not equal to 1 just in order to use our formula for the finite geometric series. So our conclusion then is that our geometric series, the sum of ar to the n, converges if and only if the absolute value is less than 1, in which case the sum of that series is a over 1 minus r. That's what we get up in here when this piece goes to 0. You're just left with a over 1 minus r. That's all for now.